Hi, my name is Jing. So this is the presentation video for my project 2 for the subject probability and statistical data analysis. So I will start with the introduction first. This project is a survey on the status of COVID-19 outbreak in Malaysia. The purpose of this study mainly about the further analysis of data obtained from the secondary data, which is DOSM, about the status of COVID-19 in Malaysia. And these are the objectives of this study. So all the data used for analysis in this project is collected from the secondary source, which is the website of Department of Statistics Malaysia, DOSM. And DOSM has specially developed a landing page as an initiative to inform the public about the status of COVID-19 outbreak in Malaysia. So all the data and statistics about COVID-19 by states in Malaysia that presented on the website are based on the official data from primary source, the Ministry of Health Malaysia and media agency. So the population counted in this project are all the people who stay in Malaysia, and the sample size is 33.78 million people from 16 states, which including 13 states and 3 federal territories. So RStudio is the only medium that used in this project for the purpose to test and analyze all the data. So the statistical test analysis related to the variables chosen are one sample test, correlation, regression, and goodness of fit tests. So according to New Straits Times, the data really showing that more than 3/4 of those who died of COVID-19 in Malaysia are men, and the proportion is similar observed across the world. So one sample test is used to test a claim where male has higher risk of death due to COVID-19 at 5% of level of significance. So at here, we set H now as P equals to 0.5. And from the data obtained, we declare these variables in RStudio. So we can obtain a population proportion is 0.5. Then we calculate Q and we obtain N is 113, X is 88, and last we get the sample proportion. So from the result, we can obtain the test statistics is 5.9265 and the p-value is this. So from the analysis of data in this project, it's found out that there is sufficient evidence to support that male has higher risk of death due to COVID-19. So death rates still on climbing for both men and women, but the numbers for men tend to outstrip the women. So here are some of the factors that discussed by others, such as the in FMT News, the British Medical Journal suggested that for more male deaths may due to some other reasons such as their lifestyle habits and prevalence of smoking. So the factors still on investigating. So the second test analysis is correlation test. So we want to know about the relationship between the variables of confirmed cases and deaths on 17th of May 2020. So the data used to measure the relationship between the variable x and y, which is x is denoted as the number of confirmed cases, while y denoted as the number of deaths. So R is the result of correlation coefficient. So I have calculated these variables using RStudio. We can obtain the answer using this formula, but it's too complicated and wasting time. Therefore, we use the formula Pearson technique to analyze the correlation. So we can also obtain the same result as the formula. So from the result, we can know that it is a strong relationship between the variables, and a scatter plot also generated, which showing that it is a strong positive linear relationship between the variables. So this is an extra part where I have calculated the case fatality rate, but due to situation of fast spreading of COVID-19, the number of confirmed deaths and cases change over time. So the CFR option cannot be used as it is extremely difficult to make accurate estimates of the true rate of death. So for the regression test, we need to determine the relationship between x and y, where x denoted as independent variable, the number of confirmed cases on 17 May 2020 according to stats, while y denoted as dependent variable, which is the total number of deaths until 17 May 2020 according to stats. So here we set h now as the coefficient are equal to 0, which means there's no relationship between new cases and deaths, while the h alternative is the coefficients are not equal to 0, which means there's some relationship between the cases and deaths. So from the result generated using RStudio above, the values of the constants are the estimate of the regression intercept is 6.0274, while the estimate for the regression slope is 0.3524. So an estimated regression line equation is generated where depth equals to 6.0274 plus 0.3524 times 100, where we estimate there is 100 cases, 100 confirmed cases happen, and we can get an estimated 42 cases of deaths. So from the table, you can see the residual standard error is 6.626. So this means the observed death value deviates from the true regression line by approximately 6.6 cases in average. So it may consider as a slightly big prediction error. So next is the F statistics equals to 3.876. So we're producing a p-value of 0.06909, which is less significant as an overall. This shows that the factor we are using, new case, is less relevant. So next is the R square. We get 0.216x, which means the new case is a weak predictor as it only able to explain 21.68% of the variation in depth. And the last is the p-values. For the independent is hardly significant, but for the predictor variable is less significant. So in conclusion, even though there's a less significant association between the predictor and outcome variables, we have to reject the null hypothesis and accept the alternative hypothesis, which means there's some relationship between the new cases and the deaths, and the coefficient is not equal to 0. So it shows only 21.68% of the variation in depth is explained by variation in new case. And from the graph generator, you can see there's a weaker linear relationship between x and y. So the findings are less suitable and less predictive to estimate a variable. The last test analysis is goodness of fifth test. So we use this test to claim whether the confirmed cases from different states are same at a significant level of 0.05. From the result, we obtain the expected value and the chi-square value from RStudio. So since the chi-square result obtained from RStudio is greater than the test statistic, 24.996, we reject the null hypothesis, and the large value of chi-square, 8,962.2, and small value of p-value, due to there's a large disagreement between the observed and expected value. So there is insufficient evidence to support that the confirmed cases from different states, including the 13 states and 3 federal territories, are same. So since there's a large disagreement between the observed and expected values, it will lead to a large value of chi-square and small p-value. And this may due to the corona disease has resulted in an ongoing pandemic. There are different clusters identified in different states, which may result some of the areas have relatively higher cases compared to others. According to a statistic today shows that most of the patients are men. Based on the result in one sample test, we can conclude that it's statistically showing men have higher risk of death due to COVID-19 compared to women. However, the factors on men comprise higher percentage of those dying from COVID-19 in Malaysia still need to be confirmed. In correlation tests, I managed to show that there is a relationship between the variables confirmed case and death. But since the result of CFR calculated previously seemed to be not accurate, so we can show the actual risk of death if we are confirmed with coronavirus. And the result of regression shows that only 21.68% of the variation in deaths is explained by variation in new case. So the above analysis also implies that new case is not a good predictor. It may be not a good example of model as it less predictive. The goodness of fit test result shows that the proportion of confirmed cases are different among the states, and this may due to new cluster detected in different states, which may result some of the areas have relatively higher cases compared to others. So I understand it's a difficult time for every one of us because of COVID-19. That's why I want to set COVID-19 as my topic for project 2. So if we don't want to be only a statistic, we have to follow all the rules set by the government during this RMCO period. So I think everything will be getting better very soon, and we can fight against the battle of COVID-19. So that's all for my presentation. Thank you.